All right, for video 3, example 3 of our 2.5 guided notes, this is one that is definitely very comparable to how we set up the proportion. Again, whenever we watched the videos about the boy who was trying to plan to meet up for dinner, and we were trying to figure out if his phone battery was going to die and when it was going to die, and we set up a proportion to be able to solve that. This is very similar to that. So here we have a verbal description, meaning more of like a word problem, comparing it to a graph. So these are the two things we're going to compare this time. So here's our situation. We have a graph, and it represents the cost per ounce of a granola cereal. That's what the graph is over to the right. Here's what else we know. We know a 15-ounce box of raisin cereal cost $3.90. So we're comparing a granola cereal and a raisin cereal. And our goal is to figure out which cereal cost more per ounce. So in other words, which one is more expensive in the long run? Let's focus on that raisin cereal first. So here's what we know about the raisin cereal. That's our verbal description. A 15-ounce box costs $3.90. So here's the first thing we're going to do, and it'll take me a second just to write it. I'm going to try to write decently small and neat. So we need to find the cost per ounce of the raisin cereal. So we don't know that. All we know is that for a whole bunch of ounces, for 15 ounces, we know what the total cost is. We want to find out, well, what does it cost per ounce? So we're going to set up the proportion like we've practiced. So that means we're going to take the $3.90 per every 15 ounces. That's how we're going to set up the fraction. OZ is for ounces. So again, that's the proportion. For every $3.90, you get 15 ounces. So in order to figure out what it is for every ounce, all you have to do is divide those two numbers. So you can use a calculator to do 3.90 divided by 15. And that will tell you 0.26, meaning it costs 26 cents for every 1 ounce of the raisin cereal. And I'm going to write that in words. So, raisin cereal costs 26 cents. Don't forget that decimal. 26 cents per ounce. Okay, so we did that part. I'm going to put a little squiggly to separate it all. Okay, so now we know how much it costs for every ounce for the raisin cereal. Now we need to go look over at the graph to talk about the granola cereal. So the granola cereal is our graph. And there's that little bubble there. It tells you to find the difference. Remember, the word difference in math class means subtraction should be happening. When you find the difference between two things, that's subtraction. Find the difference between the coordinates of two sets of ordered pairs, which are those points, those locations on the map, on the graph. You can be on a map too. And to determine the constant of proportionality. So this actually goes back to how I showed you earlier, where we ended up subtracting those y's and subtracting the x's and dividing. So we'll definitely practice that a lot more, but to show you for this example, what's going to happen is you're going to take, let me use this green color. You're going to take your y values in those coordinates. I'm circling them in green. Remember, a coordinate is labeled x, comma, y. So the second number in a coordinate is always the y value. So here's what we're going to do. We're going to take the two y values, so we're going to label them y2 and y1 because there's two of them, and we're going to divide that, so again, just setting up the proportion, by the x values. So there's two of them as well. Make sure that's an x. So that's exactly what's going to happen. So we have, for our y values, we had a 5, and we're going to subtract the 2.5. Again, where these numbers are coming from they are just points on the graph, and they were already labeled for us to help us out. Okay, so we'll do that subtraction in a minute. We got to finish setting up our fraction here. And now we need to take our x values. I'll go ahead and circle those in yellow. So we have two x values now, which would be 20 minus 10. So I'll move this down here. So that turns into 5 minus 2.5 means you're at, and remember the money is on top, so that's 2.5, in other words, $2.50 for every 10 ounces, 20 minus 10, that's where the 10 comes from. And now you just need to do your final division. So you need to do 2.5 divided by 10. And that will give you 0.25 over 1 ounce. So what this is saying is, I'm going to write it over here where I have a little bit of room over to the left. The granola cost 25 cents per ounce. Okay? So what we're trying to answer here is which cereal costs more per ounce. Well, the granola costs 25 cents per ounce, and the raisin cereal costs 26 cents per ounce. So it should be pretty obvious that the raisin cereal costs more. Okay. I want to recap on the graph really quick, because I know that if you've never done that before or seen it before, it can probably be confusing. But try not to think too mathematically about it. It's actually more of a common sense kind of thing if you think about it. Finding the difference between two locations would just be the subtraction part of it. So if you subtract the y values, which is what we did, 5 minus 2.5, and then you subtract the x values, which was the weight in ounces, 20 minus 10, that gives you what the change was between those 2 points. But in order to find per ounce, that's why we did that extra step of division, the $2.50 divided by 10 ounces, because we wanted to know how much it was for every single ounce. And again, we will practice that more as time goes on. Okay, let me see if it will let me zoom in a little bit to do that last try it one with you. Move it up. Let me see if it will let me. It kind of gets in the way, but that's okay. Let me undo that. Okay, so this last one, the distance covered by the fastest high-speed train in Japan, traveling at max speed, is represented on the graph. So the graph is talking about the train speed in Japan, specifically Japan. The fastest high-speed train in the U.S., traveling at max speed, covers 600 kilometers in 2.5 hours. We want to figure out which train has a greater maximum speed. Let's start with the U.S. first. So over here, I'm just going to say U.S. and put a colon. So here's what we know about the U.S. It covers 600 kilometers for every 2.5 hours. And I'm going to use 2.5. That's the same as 1/2. So 2.5 hours. And again, just setting up a proportion, when you do that division, 600 divided by 2.5, you'll get 240 kilometers for every 1 hour. So this is saying that this train in the U.S. goes 240 kilometers for every hour that it travels. All right, so now we just need to look over at the graph for Japan. I'm wondering if I can get this to go away as I'm writing, maybe. Not real sure about technology. If I can move that. Yay, okay. I thought that would go away. Looking at the graph over to the right with this, the train in Japan, this is really simple because we can look at the time. Time is our x-axis. Look at the time, and at 2 hours, look at where it's hitting. It's actually above 600. Look at 2.5 hours. That would be somewhere in the middle here. Like, yep, actually right here, perfect. At 2.5 hours, let me see if I can change the color on that one. See if I can get that go away again. At 2.5 hours, so that 2.5 is in between 2 and 3, it's at 800 kilometers. So look back even at the original statement that we knew. The one in Japan, 2.5 hours, it's already 800 kilometers away or traveling. This one in the US is only 600. So what we can notice here is that and a reason why we can look at it that way is because at 1 hour, it is definitely above 250. It's actually probably closer to 300. Look at how this is increasing by 200s. This will let us know by comparing those few things and looking at the graph of where the coordinates land. This tells us that Japan, that was really sloppy, but that's okay, travels faster. Again, just look at your graphs. That's why I love graphs, is because it's nice visual for you to be able to compare. Look at your graphs to be able to compare how fast it's going compared to the US train. Okay, so that's the last of these notes. Again, use these videos to help you with the practice problems. And if you need any help, just let me know.